Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 7, and today we're looking at Section 7.5, which is solving equations containing rational expressions. There are two objectives in this section. First, we're going to solve equations containing rational expressions, and then we're going to solve equations containing rational expressions for a specified variable. So those two things probably sound kind of similar right now. You'll see the difference as we get into it. Same SLO that we've been working on throughout this chapter. So before we get into it, I just wanted to give you a heads up that I have a feeling that this video might be kind of long. So depending on what happens, I might break this into two videos. So you'll know that if you see that there's a part 1 and a part 2. In that case, they won't be super long. Otherwise, remember you always have the option. Sorry, that's a bird saying hi in the background. You always have the option of you don't have to watch them all in one sitting. That's one nice thing about online. You can watch them at your own pace. All right, so I want to do a little review of expressions versus equations. We looked at this in a previous section, and I think it's especially important in this chapter. So remember, expressions do not contain equal signs. They have directions like simplify or factor. They also have directions like add or subtract. So it's important to understand that the problems we did in the last section were expressions. And what we did in the last section, we did a lot of what you see here. To change one rational expression into an equivalent expression, you do the same operation, which is almost always multiplication, to the top and the bottom of the expression. All right. I should be more specific. You can't just do any old operation to the top and the bottom of a fraction. It has to be multiplication or division. All right, equations, of course, do contain equal signs, and the directions almost always say solve. So you're going to see me work these problems in this section a lot differently because they are equations. So to change an equation into an equivalent equation, you can multiply both sides of the equation by the same number, and that number does not have to be a fraction, okay? So there is often a lot of confusion between this section and the previous section. So we're going to try to get over that. All right, so here is the batch of examples that we will be looking at. All right, so in a moment here, I'm going to switch over to my tablet. I want to give you a heads up about another thing. Rational equations always need to be checked. So you've heard me say before that it's always nice to check the solution of an equation and make sure it really works. Well, with rational equations, it's kind of necessary. At the very least, when you get your list of possible solutions, usually there's one or two, you do need to look back at your original equation to make sure that none of your proposed solutions makes a denominator 0. If it does, then you have to throw out that proposed solution. It is not really a solution. So I think this is the first instance we've ever run into where you can do all the algebra 100% perfectly, but if you don't remember to do this step at the end, you can still get the answer marked wrong, unfortunately. All right. If you would like to know why that is, why is it that you have to check rational equations? Isn't it enough to do the algebra 100% perfectly? That would actually be a good discussion topic if you're taking a class that has a discussion board. So I would love to answer that question when I'm teaching a face-to-face class. Usually I'll say, catch me in the last 5 minutes of class if you'd like to know. Most of the time people take my word for it and don't ask me for the details. I think maybe once or twice somebody has. Okay, so let's go over to the tablet. Actually, let me put you on hold for just a second. Okay, so here's our first example. This is technically a beginning algebra problem What makes it a beginning algebra problem is that there are no variables in the denominators. All right, so the first step, whether you have variables in denominators or not, is to find the LCD. So that's kind of nice. It's the same first step that we did in the last section. So the LCD that covers these is 18, right? Okay, so now what's different about this section is because this is an equation, all right, instead of trying to make all of these fractions be over 18, I'm not going to do that. What I'm going to do instead is multiply both sides of the equation by 18. Okay, so this is something that only makes sense when you're doing an equation. Okay, so here is my original equation. Okay, so let's deal with the easy side of this first. That would be the side that only has one term. X over 18 times 18. You can stick a 1 under here if you'd like to, and then the 18s just cancel each other out. Okay. So in the new improved version of this equation, the right side is just going to be X. Okay. So now let's talk about the left side. On the left side, I have to distribute the 18. All right. Hang on one sec. Okay, so we distributed the 18. All right, so what is that going to look like? We're going to have an 18 here, 18 here, and then remember on the right side, we just have X. So let's put our X over 6 and our 4X over 3. All right, so now I'm going to stick a 1 underneath these 18s. All right, and now we'll simplify those little multiplication problems. So we have a 6 and an 18. You can divide a 6 out of both of those. That leaves a 1 and a 3. And then over here, 3 and 18, you can divide out a 3. That leaves you 1 and 6. So what does that leave me with? That leaves me with 3x plus 6 times 4x, which is 24x, equals x. All right, so what kind of equation is this? This is called a linear equation. So what we do with those is we combine like terms. On the left side, we have 27x equals x. And then once the left side and the right side are completely simplified, you put all the x terms on one side and put all the number terms on the other side. So in this case, we have to subtract x from both sides. And that is going to leave us with 26x equals 0. So something I sometimes say is once an equation, always an equation. I have seen students sometimes take an equation like this, 27x equals x. They subtract x from both sides, and then they don't realize that they have to write the equals 0. And so they just get to 26x, and maybe they think that's the answer. Okay? Once an equation, always an equation. So we have 26x equals 0. We divide both sides by 26. I need to turn off my notifications. With my old system of sharing my tablet, I was able to keep my Wi-Fi off, but now I can't. All right, so this gives me x equals 0. All right, so one last thing to talk about. Do I have to worry about that x equals 0 making any denominator 0? Well, my denominators are 6, 3, and 18. And those are never going to be anything other than 6, 3, and 18. All right. So my shorthand notation to indicate that I have checked my solutions to make sure they don't make any denominator 0, I just put an OK under it. It's never a bad idea to do a full all-out check. That would be pretty easy for this problem. It would just be 0 over 6 plus 4 times 0 over 3 equals 0 over 18, which is just another way of saying 0 plus 0 equals 0. All right. All right. And that takes care of letter A. All right. Next example, 6 plus 5 over y equals y minus 2 over y. All right. So first I find my LCD. In this case, the only denominator is y, so that makes that pretty easy. The LCD is y. All right, so remember what we did in the last problem. We multiplied both sides of the equation by the LCD. All right. So you see this time I'm going to have to distribute on both sides. All right, distribute on that side, distribute on this side. All right, so that is going to give me a y attached to each and every term. And those original terms were a 6, a 5 over y, a y, and a 2 over y. All right, so once again, if you find it helpful, at least for this one and this one, you can put the 1 underneath. All right, so my new and improved equation is going to be 6y plus, these y's are going to cancel and just leave me a 5. Y times y is 2y? No, it's y squared, right? All right, and then these y's cancel and just leave me a 2. All right, so what do we call that kind of equation? That is a quadratic equation. We talked about those in chapter 6. So this is very much a Math C problem. We wouldn't have had this in beginning algebra. All right, so what do we do with quadratic equations? We put them in standard form, everything on one side. And in this case, I think I'm going to make that the right side. I kind of like that y squared exactly where it is. So let's get rid of all this stuff. All right, and then that is going to give me 0 equals y squared minus 6y minus 7. All right, so these problems tend to be a little longer. So I went ahead and left a blank page right after that page. So let's write that equation as y squared minus 6y minus 7 equals 0. And of course, we solve those by factoring. So the numbers that add up to -6 and multiply to -7 are -7 and +1. And of course, if y minus 7 times y plus 1 is 0, that means y minus 7 is 0, or y plus 1 is 0. And of course, if y minus 7 is 0, that means y equals 7. And if y plus 1 is 0, that means y is -1. All right, now don't forget, we started with a rational equation. So we need to look at our original equation. Does the 7 or the -1 make any denominator 0 in the original equation? Well, no, 7 makes a denominator 7, and -1 makes a denominator -1. So I think we're okay. The solutions of this equation are 7 and -1. This equation has 2 solutions. All right, next example. And again, As usual, I encourage you to pause the video and try one of these whenever you're feeling, as I say, feeling frisky. All right, feeling confident, um, or just feeling brave, you know. Okay, now I have two different denominators here that do not have any factors in common. So that means the LCD for these two is going to be y minus 3 times y plus 3. All right. If I remember correctly, I think this is a pretty long problem. Some of them are. Okay, so we have to multiply both sides of this equation by y minus 3, y plus 3. And part of that is going to be easy. The other part's going to be a little less easy. The part that is easy, I think, is this part over here, because again, it's just one term. So maybe we'll do that part first. The part that's going to be a little less easy is going to be this part over here. Okay, so let's start with the right side. What do we have over there? Put a 1 under here. My y plus 3 can come out. Which means the new and improved right-hand side is 3y minus 1 times y minus 3. All right, so now I have to distribute the y minus 3, y plus 3. That goes here and here. Okay, now I'm going to try to show all my work. It's going to be a little bit of a tight squeeze. This is where I miss having a real whiteboard. Okay, so those are going to get multiplied together, and then over here it's going to be minus 3 times y minus 3 times y plus 3. Okay. All right, so what do we have over here? We can cancel a y minus 3. All right, so the new and improved equation, I say improved because at least it's not going to have any fractions. That doesn't mean it's going to be the easiest equation in the world. But at least it doesn't have any fractions. That equation is going to be 4y times y plus 3 minus 3 times y minus 3 y plus 3 equals 3y minus 1 times y minus 3. All right, so what I would like you to do next, and of course I'm going to do it, is to multiply those expressions together. So I kind of see 3 expressions there. Go ahead and multiply those together. And I think what we're going to find is that this equation is going to end up being quadratic. Okay, so try that and then come back when you're ready to compare notes. Okay, so hopefully you had a chance to try that. This one is going to be 4y squared plus 12y. Now the next one I'm going to do in 2 steps. I'm going to leave the minus 3 for the next step, and I'm going to multiply these two to start with. So hopefully you recognize that pattern. That is, well, that's going to end up being a difference of 2 squares. That is y squared minus 9. All right, and then these two you just FOIL. 3y times y is 3y squared. And then I'll do the outer and the inner together. Minus 9y minus y would give me minus 10y. And then negative 1 times negative 3 is plus 3. All right, so while we were paused, I went ahead and wrote that step at the top of the next page. So now what I'm going to do is distribute this negative 3. Notice it is a negative 3. I will admit one super annoying thing about long problems like this is you make one little mistake and it's basically over. All right. But that's just the way it is. Fortunately, you get better at not making those little mistakes the more you practice. Okay, so this is definitely looking like a quadratic equation, which means I need to put it in standard form. So I think I'll start by combining these like terms. That's going to give me y squared plus 12y plus 27 equals 3y squared minus 10y plus 3. All right, and now I am going to move all the terms to the right-hand side again. And the reason I'm doing that is because this y squared term has a bigger coefficient than this one, which means if I put them on the right side, I don't want you to think that that's a division sign. I knew that was going to happen. I'm going to get a positive coefficient on the right side. Here we go. That's pretty good. Okay, I was doing this in red, right? Okay, so that's gone. I need to get rid of this. And I need to get rid of this. Goodbye, goodbye. All right, so that leaves me 0 equals 2y squared minus 22y minus 24. We're almost done. So now we have to factor that thing. I will start by pulling out a 2, which leaves me y squared minus 11y minus 12. Now I need two numbers that add up to negative 11 and multiply to negative 12. That would be minus 12 plus 1. All right, so one of those things has to be 0. I know it's not the 2. It's got to be either the y minus 12 or the y plus 1. All right, so it looks like we're going to get two possible solutions. One is y equals 12. The other one is y equals negative 1. All right, now don't forget there's one more little thing we have to look at. Does either one of those make a denominator 0? Well, let's see. The original denominators were y minus 3 and y plus 3. The only numbers that would make either one of those 0 would be a 3 or a negative 3. And since neither one of my possible solutions is 3 or negative 3, these are both okay. And my solution set is 12 and negative 1. Whew. All right. All right. Hopefully everybody's hanging in there. Nobody's injured. Next example, 1 over x plus 2 equals 4 over x squared minus 4 minus 1 over x minus 2. All right, so since x squared minus 4 factors into, you know what, let's just write it on the next line. That factors into x plus 2, x minus 2. That's going to help us figure out our GCF. And since I see the factor x plus 2 one time, or I should say the highest power I ever see it is first power, and the highest power I ever see x minus 2 is first power, that means that the GCF is x plus 2, x minus 2. All righty. This problem is a little shorter than the last one, thankfully. All right, so let's start with the left-hand side this time, because there's just one term over there, so I can sneak a 1 under here and just get rid of the x plus 2. Okay, had to do a little change of venue there. Birds were starting to get noisy. All right, so we've multiplied through by our LCD. On the left side, that gives us x minus 2. Let me Just, all right. And then on the right side, we had to distribute x plus 2, x minus 2. So what's that going to look like? We have 4 over x plus 2, x minus 2. That is now being multiplied by x plus 2, x minus 2. And then we have minus 1 over x minus 2. And that is also being multiplied by x plus 2, x minus 2. All right. So sneak a 1 under here and here. Over here, everything is going to drop out and just leave us a 4. And over here, the x minus 2 is going to drop out. So our new improved equation is going to be x minus 2 equals 4 minus. Now here, you have to be very careful. We are subtracting x plus 2. So you don't want to write this because that is not subtracting x plus 2. That is subtracting x and then adding 2. The x plus 2 has to go in parentheses. All right, so believe it or not, that is a nice little linear equation. It simplifies to x minus 2 equals 4 minus x minus 2. Now we can combine like terms. Let's take this, well, let's see, that's going to give us x minus 2 equals 2 minus x. All right, so let's continue that over here. We have x minus 2 equals 2 minus x. Since it's a linear equation, we need our x terms on one side, let's say the left side, and we need our number terms on the other side. Goodbye, goodbye. So that leaves us 2x equals 4, which means x equals 2. All right, so that is a possible solution. Let's look at our original equation. The original equation has denominators x plus 2 and unfortunately x minus 2. Our only possible solution is x equals 2. Putting x equals 2 into this equation would cause a 0 denominator here, which is enough to wreck the whole thing, but also here, okay? So I'm sorry to have to tell you this, but when your only possible solution makes a denominator 0, that means there are no possible solutions. This particular equation has no solution. I hear sometimes students get very disappointed when there's no solution. They feel like the problem was a big waste of time. I don't feel that way, but I get it, all right? But hey, it's something we didn't know before, all right? We had no idea what the solution was of this equation. Now we know there isn't one, okay? All right, so next example. Add 27 over y squared minus 81 plus 3 over 2y plus 18. So I guess the first thing I should do is factor my denominators. So over here we have a difference of 2 squares. That's going to give me y plus 9, y minus 9. And over here I can factor out the 2, and that's going to give me 2 times y plus 9. So I see 3 different factors there. I see a 2, only ever to the first power. I see a y plus 9, only ever to the first power. And I see a y minus 9, only ever to the first power. So the LCD is 2 times y plus 9 times y minus 9. So here is my question for you. Should I do this? Does this seem like a good thing to do? Ah, come on. Okay. Seems kind of like what we've been doing. Well, actually, no, that is not a good thing to do. And here's where that expressions versus equations thing comes in. Every example before this has been an equation. So we've been able to multiply both sides by the LCD. This is an expression, all right? So the only way to balance an expression is on the top and the bottom of the fraction. So what I've actually done here is sneak in a section 7.4 problem. Okay, not trying to trick you. You know, you just have to be able to tell the difference between these kinds of problems. So what did we do in section 7.4? We still found the LCD, but then what we did with it was we tried to build that denominator, right? So we did something to these fractions so that their denominators would be 2 times y plus 9, y minus 9. You remember how we did that? We looked at what we were missing from each denominator and we multiplied that on the top and the bottom. So what I'm going to do to this first fraction is multiply the top and the bottom by 2. What I'm going to do to this second fraction is multiply the top and the bottom by y minus 9. All right, so my new numerator will be 54, 2 times 27. And over here, my new numerator will be 3 times y minus 9. Okay. All right, so now that they have the same denominator, we have one great big fraction with denominator 2 times y plus 9, y minus 9. And let's do this. The first denominator is 54. And then if you don't mind, I'm going to go ahead and distribute that 3. That'll save us a step right here. So that's going to give me 3y minus 27. Okay, almost done. Combine like terms in the numerator. 54 minus 27 is 27. So this is going to become 3y plus 27 over 2 y plus 9, y minus 9. I wish I could copy and paste on here. Just rewriting that last step. Okay, and now I'm going to try to simplify this thing. We didn't have much luck in the last section simplifying any of our answers, at least not when we got into the really interesting problems. But this time I think I can, because if I factor out a 3 on top, that leaves me y plus 9. And guess what? Y plus 9 happens to be one of my factors downstairs. So the simplified form of this sum, remember this was an addition problem, is 3 over 2 times y minus 9. All right, so that's going to do it, not for this whole section, I'm sorry to say, but for the first objective. Second objective is much shorter. So let's go back to the presentation. Okay. All right, so we're on to solving an equation for a variable. When we talk about a literal equation, these are also called formulas. I think literal equation is kind of a sort of antiquated, old-fashioned term. A lot of books now call them formulas. Again, an equation with more than one variable. So I came up with this crazy example here. No, we're not going to do anything like this. All right, this is a meme I dug up a few years ago. Ask students to solve a literal equation with more than one variable in it. Everyone loses their minds. Well, yeah, because, you know, what do they always say? When you start putting the alphabet in math, that's when everybody loses it. I get it. Okay. So before we start solving equations for variables, we need to talk about what it means to solve for a variable. So for example, if it says solve for x, that means two things. It means to get x all by itself on one side, and I think most people understand that part. But it also means that x cannot appear at all on the other side. All right. Years and years ago, I had a student who was originally from, I believe, Nigeria. And she told me something really interesting. She told me that in the textbooks they used in Nigeria, instead of saying solve the equation for x, the directions in the textbook would say make x the subject of the equation. And I was like, wow, I like that a lot better. I think that does a better job of sort of explaining what you're doing. Okay, I've never forgotten that. All right, so I have just a couple examples of this. We're solving each equation for the specified variable. The first one is I equals A over T plus B, which I believe is some sort of formula that's used for something to do with the weather. It is a real formula. They didn't just make this up. And we want to solve that for T. The next one, I think they did make this one up. Although I've seen word problems where equations like this come up. So this is a good thing to be able to do. 1/5 plus 2 over y equals 1 over x. We're going to solve that for y. All right, so let me pull that up on the tablet. All right, here we go. I equals A over T plus B. We want to solve that for T. So if you notice that the variable that you're trying to solve for is in a denominator, then the first thing you're going to have to do is get rid of all your denominators. And the way that you do that is by multiplying both sides by the LCD. And in this case, that's just T plus B. I like when there's only one denominator. It makes it really easy to figure out what the LCD is. All right, so we have I times T plus B equals A over T plus B times T plus B. All right, so nothing happens on the left side. That's just going to become I times T plus B. On the right side, T plus B's are going to cancel and just leave me A. So in this kind of problem, you might want to constantly remind yourself, what is it that you're trying to do? You're trying to solve for T. So I see two good ways to do that. All right. And I'm just going to do the one I think of first. All right. If I'm trying to solve for T, I see that one thing standing in my way is that letter I. So let's get that out of there by dividing both sides by I. So that is going to give me T plus B equals A over I. All right, and now it's real easy to solve for T. You just subtract B on both sides, right? Okay, so for this kind of problem, you know you are finished when, again, you have T all by itself on one side and T not appearing at all on the other side. All right, that's it. So on a scale from 1 to 10, I give that problem about a 3. All right, that's a pretty easy one. The next one is quite a bit harder. We want to solve this one for y. Y is in a denominator. So the first thing I'm going to do is figure out my LCD. I see 3 different distinct factors that have nothing in common, 5, x, and y. So my LCD is going to be 5xy, right? Okay. Okay, so we're going to multiply that by 1/5 plus 2 over y. We're going to multiply that by 1 over x. So as usual, we'll do the easy part first. On the right side, the x's cancel. So that's going to give me a 5y there. On the left side, I have to distribute 5xy. Okay, so we have 5xy, 5xy. Sorry, that kind of looks like an 8. Times 1/5 plus 2 over y. All right, so over here, the 5's cancel. Over here, the y's cancel. All right, so our new and improved equation is going to be xy plus 10x equals 5y. Let me copy that onto the next page. Xy plus 10x, xy plus 10x equals 5y. All right, so what was the question again? I think we were supposed to solve for y. That's right, that's what I thought. Whoops. Okay, now I'm going to tell you about a trick that'll be good to have in your bag of tricks. All right, this will come up in different problems. Notice that you have a y term on the left side and you also have one on the right side. So in case your first thought was to divide both sides by 5, that would give you a y all by itself on the right side. So it would fit, it would check one box for solve for y, but you'd still have the y on the other side. So it wouldn't check the other box. So what you have to do in a situation like this, I'm just going to tell you down here, when it says solve for y, of course, substitute whatever letter happens to be there in your particular problem. The trick to have in your bag of tricks is this: get all y terms on one side and all non-y terms on the other side. Ugh. Okay, that didn't quite work out. Get all y terms on one side and all non-y terms on the other side. Okay. All right. So let's see. I have a y term on the right side. So why don't we put the other y term over there next to him? So we're going to go minus xy minus xy. So that's going to give me 10x equals 5y minus xy. Bam. I have a non-y term on the left side and I have all y terms on the right side. So the reason we do this, get all the y terms together on one side, is because we are now going to factor the right side. We're going to factor out the y. And my other factor is going to be 5 minus x. And now I bet you see how I am going to get y all by itself. I'm going to divide both sides by 5 minus x. Ta-da! All right, so we have y equals 10x over 5 minus x. Y by itself on one side, no y on the other side. All right, and at long last, that is going to do it finally for section 7.5. We'll see you next time.